Okay, we are going to start the discussion with the zoning regulations today, which I already mentioned in the last lecture as well. So, zoning regulations provide you the legal requirements for minimum number of parking spaces, and they are enforced by the government, and they differ according to the size and the type of facility. And these zoning regulations also consider the standards related to handicap parking and loading zones. So specific parking needs are also incorporated in them. Now, when it comes to shared parking, there can be three different arrangements which can be employed through the zoning regulations. The first is you have multiple sites, and one area is specified for all of them, and that area is at a walking distance, at an acceptable walking distance from all the sites. Okay, and again, you have to keep in mind that the peak demand for all these sites should be at different times, otherwise that area may not be enough for them. The second is the government has a particular parking facility, and the developer is supposed to pay a particular fee to the government to use that facility. So that facility will be made available to the developer, the clients of the developer, on the payment of that fee. And the third option is that the businesses themselves in a specified area, they are uh, given a specific facility, or the area, the total parking supply in the whole area is available to them, and for providing this facility they pay a tax to the government. So it's not for one developer or a group of developers. Anybody who is doing business in that area uh, is liable to pay the tax, the extra tax, and in return he would get the parking facility for his clients. And in this case, the government is maintaining the parking for the entire area. It could be on a street, off a street, in the garage, or in a building, or whatever, or it could be a multiple of these options. So when you have dense urban areas where there's population density is very high, then we should look for providing public parking spaces, because providing private or exclusive parking spaces will eventually require more area. And we should also look to promote walking, bicycles, and public transport option in those areas to reduce the parking demand. Otherwise, you will not be able to fulfill it. Okay, so these are the zoning regulations given for different types of land uses, and these are from US. And any particular government may have their own zoning regulations. These are usually slightly higher than the parking demand we are expecting from the parking generation rates. So these are the handicap requirements. For any particular facility, at least one handicap parking should be there. Any facility which is used by general public. Okay, so we are not talking about houses. Okay, so we are talking about maybe malls or office buildings, something like this. So at least one is required, and then more than one, you have to follow these standards. So let's say we have a general office building which consists of 50,000 square feet of office space. What is the peak parking load expected at this facility, and what will be the recommended zoning regulation in this case? Now, we already did this example in the previous lecture, so I already know that using the average parking rate, it gives me 142 spaces, and using the equation from ITE, it gives me 152 spaces. Okay, so now let us look at, if I apply the zoning regulations, then what will happen in that case. I zoom in, then you can see that general office building is here. Okay, and my area is 50,000 square feet. So this is the requirement then. Okay, if it is more than 30,000 square feet, then 3 per square feet. Okay, so my area is 50,000 square feet. 3 per square feet means 3 into 50. So that gives me 150 spaces. Now you can see that the average rate is giving me less than the zoning regulation. So this one then cannot be used. You can use 150 or 152. Okay, so the law has to be fulfilled. The zoning regulations have to be fulfilled. Okay, when we are doing parking studies, we are looking at four critical elements: duration of parking for specific users, accumulation of cars in the parking area at a particular time. Accumulation means number of cars in the parking area at a given time. Proximity requirements means the walking requirements, okay, or the preferable walking distance to the parking area according to the users. And duration and accumulation are interrelated to each other. How? I will show it later on. And it's mentioned here as well. Vehicles which are parked for longer duration. If number of vehicles from this category increases, that means the accumulation will be higher, because you will have more vehicles which are parked for the whole day or for longer time. Then more duration usually gives you the number of vehicles which have longer duration, gives you the minimum accumulation. Okay, so proximity, as I mentioned earlier, is the walking distance for the users, for the parkers. So it depends upon the purpose of the trip and the area of the size of the area. So if the purpose is short, the purpose requires short duration, then the user will try to find the parking nearer. Okay, so his walking distance requirement will be less. Okay, so if you are just going for shopping, it will just take 2 minutes in the shop. So we'll try to park as close to the shop as possible. If you are going to the office or you are coming to your residence and you will park your car for hours now, so you may be willing to walk more distance, because you know once you park there, you are not going to come back again in hours. An urban area size, meaning the population, if the area population increases, then again the users are willing to walk more distance because they see the area is congested. This is, I already mentioned, if you are parking off street, so if it's in a garage, then it's considered more secure, and then the walking distance is usually higher. The preferable walking distance is higher because of the added security it's providing. Okay, so in many cases 1200 feet is considered as an upper limit, so the parking area should not be more than this in any case. And 75% parkers or users can walk up to 0.25 miles for their destination, from the parking to their destination. How do I know about the proximity requirements? I have to do interview studies, because otherwise there's no other way to know the preference of the road users or the parking users for their walking distance. So you can see that as the distance is increasing, the number of people who are willing to park is decreasing. Okay, this graph is showing according to area population. Area population means area is becoming more congested. The users are willing to walk longer distances because they realize the parking problem in a congested area. Then this shows in different countries and different types of trips. I already mentioned, if the trip is shorter duration, the walking distance requirement will be lower as well. Okay, then we have the parking inventory. Parking inventory means the record of the parking supply, the record of the parking spaces, and this should include where are the parking spaces, their location, for how much time each parking space is available, and the type of parking facility you have. It could be on a street, off street. Off street could be a lot, a garage, a parking complex, and so on and so forth. How do you take parking inventory? You have to take a round in the area and just note it down visually, manually. You may use sensors and tags as well. You may have seen them in the malls, that they put sensors on the parking spaces to know how many parking spaces are available, and these sensors can be counted, and they can give you the inventory of the parking spaces and their type and everything. And you can use parking tags on the vehicles as well if the parking is paid. So vehicle enters, the sensor captures the tag of the vehicle, and it will be billed to the parker, the driver, later on. Okay, before you take the parking inventory, you should pre-code the area. So you should give coding to different parts of the area, so it becomes easier for you to report. something like this. So these numbers are basically codes given to different parts of the area, 1 2 3 4 5 6. These are the block numbers, and this is the pre-coding we are talking about. This is an inventory sheet, so you type the area, the date, which block, which type of facility you are doing, okay, which is street, and you put the number of parking spaces here. Okay, so this is for on-street parkings, this is for off-street parking, and then there's a total here. Okay, it may happen that you are looking at a parking lane or a space, parking space, but you cannot see the markings for each parking space. Then you take the total length, and then you see what type of parking is allowed or used there, and then you can use one of these ratios to find out how many parking spaces can fit in that much length. Okay, so if parallel parking is allowed or being done there, then you will consider each parking space to be 23 feet. For angle parking, 12 feet. For 90-degree parking, 9.5 feet. The inventory and the parking studies are usually done for a period of 8 to 11 hours. These are considered the business hours, the working hours. Okay, the inventory can be also calculated how many vehicles can use the parking area, and this is the equation for that. So F is the efficiency factor of the parking area. I already mentioned that all parking spaces are not used. Some of the spaces are unutilized because they are at peculiar places, maybe in the corner near the pillar, or people don't want to spend their time in looking for one parking space out of 100, or someone has not parked properly, he is occupying half of the other space as well. So because of these reasons, the utilization of the parking area is not 100%. So they have given us a range which is between 0.85 to 0.95. So 5 to 15% is the wastage. Then what else do we have in the equation here? We have N, which is the number of parking spaces, T, the time for which they are available, okay, and D is the average duration of one person for parking. So for example, we have taken a 11-hour study. Okay, this one should be 11 as well. So in that 11-hour study, we found that there are 450 spaces in the area which are available for full 11 hours, 280 for 6, 150 for 7, and 100 for 5 hours. One person usually requires the area or the space for 1.4 hours. So this is the average duration. We are assuming an efficiency factor of 90%, 0.9. So how many vehicles can use this area? P equals, so I will take the efficiency factor and multiply with the number of spaces and their duration. So 450 for 11 hours, 280 for 6 hours, 150 for 7 hours, plus 100 for 5 hours means 500, divided by the duration. So using this space can be used for 5842 vehicles. Okay, so this area can be used in this 11-hour period by 5,842 vehicles with an efficiency of 90%. Okay, this graph shows the accumulation. Accumulation, as I already mentioned, number of vehicles in the area at a given time, and this graph shows you the accumulation with respect to the population of the area. So you can see when the population increases, accumulation also increases. Population means more people means more cars, so accumulation will increase. And then you can see they are showing it in different years as well. So as we are going further in terms of time, you can see accumulation still increases, and this is related to population and vehicle ownership. Both these things have increased, especially in these years in the US. Okay, so population, and same thing happens in Bahrain as well. It has happened in the last 2-3 decades. Population has increased and vehicle ownership has also increased. Number of vehicles per person or per family has also increased. So accumulation will also increase. The utilization of the parking area is increasing. So parking duration, as already mentioned, the time for which a parking space is occupied by one user, and we use average value for the calculations, but we need to know the duration, the distribution as well, the range as well. Why? Because if the range is very short, for example, it goes from 1.9 to 2.2, for example. So, and the mean is 2. So you know that everybody is almost in the same duration. Okay, so that means everybody is there for the same purpose. But if the range is from 5 minutes to 3 hours, okay, then it means that there are some people who are just there for a very short trip, and there are some people who are there for hours. So that's why it's important. It can give you an idea about the purpose, the trip purpose. So this uh, graph shows your duration according to population. Okay, so population increases, area becomes more congested, then people usually do not take their vehicles for shorter durations. And in populated areas, you will find the other options as well. So people who are taking their car, then they are going there for a longer time. And this shows you the duration according to trip purpose. Okay, shopping, business is low, work, education is higher, and so on and so forth. Again, the effect of population as well, which I already explained. Okay, if you want to do an accumulation and duration study, and so let us focus on street parking for the time being. So you give observer a block to observe, and this observer will go through the entire block, and he will see or observe the parking spaces which are filled, and he will note them down. How to note them down? We'll talk about it. Then the same thing will be repeated by this observer after a specific interval, and that interval could be between 10 to 30 minutes. So after every 10 to 30 minutes, you will give him the interval. It's not random. So he will take another round, and he will note down which parking spaces are filled by which vehicles. If you give him an interval less than 10 minutes, it will be problematic for him, because he may take 10 minutes just to do one round. So after 10 minutes, he will do another round. So he will keep on going. There's no rest for him. If you give more than 30 minutes, then there's a chance that some vehicles may come and go, and they are not recorded at all. More than a 30-minute period may have vehicles which have just come and gone from the area, and it was within the interval. So the observer did not see them at all. This is a reasonable expectation that if you are giving a block which has 60 spaces, an interval of 15 minutes should be enough for that observer. This is an observation sheet. So here you have the space, here you have the intervals, okay, and if the space is unfilled, then you put a dash there. The space is filled, you put the license plate number, the registration plate number of the vehicle, and if the space is filled in the next interval by the same vehicle, then you put a tick there. So tick means it's the same vehicle, because we need it for the duration. And number means it's a new vehicle in that space, and dash means the space is empty. Okay, so if I want the accumulation, so at this interval, how many spaces are occupied? You can count how many numbers or ticks are there. Okay, so 1, 2, 3, 4 here, and then 1, 2, 3, 4, 5 in the next interval. So you look at the column and you do the summation of numbers and ticks. This will give you the accumulation. Okay, for duration, then you have to see one vehicle is parked for how many intervals. Okay, so for example, this one. So this one is only parked for this interval. Next interval, there was another vehicle. So for this vehicle, the duration is only half an hour, because each interval is half an hour. This vehicle is observed for 2 intervals. So 2 intervals means 1 hour. So this is how you get the duration for each vehicle. You would just multiply with the number of intervals it has. Then you may also put some marking for illegal parking or something like this, any violation. So you may, I believe these circles are indicating any violation, parking violation. Okay, once you collect this data, what do you do with this? You can calculate the average duration using this equation. So we are doing the summation. Number of vehicles for X duration. The value of the duration X multiplied by the duration of one interval. So in the previous case, the survey was done for 4 intervals. So we can have number of vehicles which were parked for one interval, number of vehicles parked for 2 intervals, 3 intervals, 4 intervals. Okay, so x can be 1, 2, 3, or 4, and duration of each interval is 30 minutes. Okay, so I will be 30 minutes. Okay, and nt is the total number of vehicles observed in this area. Okay, so we will do an example in the class then later on.